Good evening. All right, today we'll move on to the next concept. Okay. So before we actually move on to the next part, okay, let's look at something that you have actually seen before. Okay, back in the other forms. Okay, now we're talking about graphs. Okay, under graphs, okay, what you have seen is, for example, you've got four types of graph that you actually seen or drawn before. Okay, so if you have a graph of this sort, this is known as a linear. Okay, a linear graph. This is called a quadratic curve. This is a cubic curve. And this is an inverse graph or a reciprocal graph. Okay, so we have seen all these four types. All right. Okay, now what we are actually going to specify under the next topic will be this type of graph. Okay, the linear graph, or it is actually known as the straight line. Okay, the straight line graphs. Okay, now basically for a straight line graph, every graph that you draw actually will have its own equation of functions. Okay, so for this kind of graph, okay, a linear graph or a straight line, it also has its own equation. Now this equation is, this is called a straight line. So the equation of a straight line graph will be written in this form, whereby you will say y is actually equals to mx plus c. So m here stands for gradient. Okay, gradient means the slope of the line. Okay, some lines are steeper compared to the other. So when the line is steep, we say the gradient is high. Okay, when the steepness is not that much, okay, it's a low lying line, so we'll say the gradient is smaller. So m stands for gradient and c is actually your y-intercept. So you actually need the gradient as well as your y-intercept, okay, to mark points, 2 points on a Cartesian plane to actually connect to form a straight line. Okay, all right, so that's the first part. Okay, now the second part is, we come back to this, okay, this concept. Okay, so you have got a gradient of a straight line. Equation is given as y equals to mx plus c, whereby m stands for gradient and c stands for your y-intercept. So one example will be, let's say we have a simple example like this, y equals to 4x plus 8. So the gradient of the equation here is 4, this m value, or we write it as m equals to 4. So when you see the m actually denotes gradient, or we write it in word form, gradient equals to 4, m equals to 4. And you have your y-intercept, this stands for your y-intercept equals to 8, or we use the symbol c equals to 8. Okay, all right. Okay, now we run through what we have already seen earlier on. Okay, under the concept of gradient, this is your m, this is your gradient. Now how do you calculate gradient? For sometimes certain equations, when it's given, you can actually just rewrite the values from the given equation. But let's say you're given a formula on how to find a gradient. Okay, gradient equals to, this is y2 minus y1 over x2 minus x1, whereby x1, y1, x2, y2 are actually coordinates on the Cartesian plane. Okay, so a simple example, okay, let's say you have a line and I've got two coordinates here. Okay, all right, 4, 6 and 0, 3. Okay, two coordinates. Okay, by using this formula, y2 minus y1 over x2 minus x1. So it will be 6 is my y2 minus y1, which is 3. So 6 minus 3 over 4 x2 minus x1, 4 minus 0. So when you simplify this, you actually get 3 over 4. Now, which is your x1, y1, x2, y2? It depends on you. Either one of the coordinates can be x1, y1 or x2, y2. Okay, that you decide. So this is the formula on how we calculate our gradient. Okay, all right. Okay, so now let's say another question. You're given a line like this. Okay, you are given two coordinates, -2, 6. Okay, and the other one is 5, -1. So again, the formula is the same. Y2 minus y1 or x minus x1. Okay, so here this one will be 6. The formula is minus, so minus bracket, this -1 is actually from here. So it's minus -1 over -2 minus 5. -2 minus 5. So we actually get 7 over 7, which is -1. So if you noticed earlier on, from our gradient, the gradient that we calculated, we actually got a positive value. And if you look at the line drawn, okay, it is situated this way. So now here gradient is positive. But whereas for your second equation, if you notice, when the line is drawn this way, our calculation of gradient is negative. Okay, so there are two things you can actually obtain from our calculation. This is just a general, it's a knowledge that when you actually look at a graph, okay, what kind of gradient actually going to, is it going to be positive or is it going to be negative? So that means if the line is drawn this way, okay, this way, gradient is always positive when you calculate. Whereas if the line is drawn this way, the gradient becomes negative. Okay, how do I know? Okay, you always check the angle between the line and the x-axis. If it's an acute angle, angle here is an acute angle, means it's actually a positive value. Here, this one, if you notice, line and your x-axis, this is an obtuse angle. Obtuse means my gradient becomes negative. Okay, all right. Okay, so this is just an introduction of our straight line. Okay, straight line concept. So we learned two things today. Number one is on how to write your equation of a straight line in terms of y equals to mx plus c, where m denotes gradient and c denotes your y-intercept. Okay, and the two types of gradient: positive gradient and negative gradient. All right, thank you.